Testing. Hello, welcome to DNSSD. This is our only session of the week, and we'll run for 90 minutes, so until 11 o'clock. Do you want to take us through to the, yeah. So this is the IETF note well. It is a reminder about the processes and policies, including about conduct, privacy, and intellectual property rights. You agree to follow this reminder when you participate in the IETF. So please read it carefully. You're encouraged to read the source documents to which the note well refers. If you have questions, please talk to us or an area director. So if you're in the room, please make sure you're signed in to the session on Data Tracker. You can use the QR code, which we are not showing. But you'll find it in Data Tracker. Just click the on-site tool. Keep your audio and video off if you're not using. And if you join the queue, please state your name. So those are some resources for the working group, which you can find later in the slides. Next slide. So I am Chris Box. I'm one of the chairs, and
I'm Florian Officer, another chair.
Next slide. Right. Stuart has kindly volunteered to help take notes. Is there anyone who can back up Stuart while if he's contributing to the session? Just to take notes of whatever. Yeah, Esco, thank you. These are some useful links for the working group. If you have any questions, contact the chairs. And we have a GitHub repo. The working group documents are maintained there. If you have an additional document, you can also contact us to get set up in that repo. Now, these are statuses of all the current of the working group documents that we have. So the ones in green there, we successfully published back in June. Multiple queue types, that status has, well, it is technically still in Shepherd write-up, but thank you, Tim, for making revisions to that write-up. So we'll be sending that off today. So it will be in Eric's inbox. So then we have TSR advertising proxy and SRP replication. We're not planning to talk about replication today. We'll talk about the first two of those. If you go on to the next slide. So we're also going to talk about these individual drafts. So this is the agenda that we are planning to work through this morning. Is anyone any request to bash that agenda? You sent errata to the list. Okay, so when you're requesting to talk? Okay, we'll do it at the end. All right, thank you. So, as I mentioned at the last meeting, so we have a charter that needs refreshing. So this is what you see there is the set of goals in the charter. There's also lengthy descriptions of the background to guide readers as to what we are doing here. In terms of updating these goals, so obviously we're not doing those things particularly anymore. If you go on to the next slide. So this is an open question. What do you think this working group should be working on next? So I've put in some ideas here based on the things that I'm aware of that we probably should be progressing. So we've got publishing SRP registered names in multicast DNS. We've got a few different mechanisms that aim to improve the efficiency, the availability, or the effectiveness of DNSSD. We've got how to do conflict resolution between competing updates for the same name, and also how the different protocol components can be combined to make a complete DNSSD service that's equally accessible. And finally, at the bottom there, we could adopt work that improves the underlying technology on which our protocols rely if the area director agrees. So does anyone have any thoughts about what should be in the charter for this working group for the rechartering? If you do, just join the queue. Eric.
So Eric Link, the responsibility for the DNSSD. So I really encourage people in the room to comment on this. As mostly with the chair, will be working and rechartering in the coming weeks, where your feedback will be welcome again. But let's maybe talk to it today. My only comment on this, by the way, will be on the last line. This is way too open in the charter. So either we commit to do it in the list of deliverable, or you remove it. That's the IEG couple of years now refused to get something which is too vague, basically.
Okay, Ted.
Yeah, so I think I'm assuming that the resolve conflicts thing is referring to TSR, and if so, that's probably not the right thing to say, because TSR is not about resolving conflicts. SRP actually solves the resolving conflicts issue. What TSR is about is prioritizing fresh over stale data. So we kind of, when we started defining TSR, we thought it was about conflict resolution, but it's really not. So I just wanted to make that a little clear.
Would you say it's resolving conflicts in a better way than it would?
No, because it's not about resolving conflicts. It's actually it was a really bad mistake to think it was about resolving conflicts, and we tubed on that for like 2 years before we finally figured it out.
Okay. Would you be able to propose?
Yeah.
Wording. Cool.
Of course.
And I think I stopped you before you were going to say something else.
Oh yeah. So and the other thing is, it's pretty clear, and you'll see this in some of the items that are on the agenda now. I mean, one of the items on the agenda is actually that exact thing at the end there, which is the last bullet point, which is great. But part of what we need to do is we've sort of discovered that there are some things that we didn't anticipate in the SRP protocol, and so doing fixes for that seems like it's also in charter, and sort of generally doing fixes for DNSSD is in charter, I think, or should be in charter. It might be nice to refer to specific action items so that we don't create something incredibly open-ended, but But generally speaking, that's something that either, if it's not in the charter at any given time, then we would probably have to recharter to add it if we discover a new thing that we ought to fix in SRP.
Okay, thank you.
Yep.
Francois?
Yes, so a bit echoing back what Ted just said. So some items that we would like to work on is especially improving, I don't know if the efficiency is the right word. I think it is. It's improving SRP in some scenarios that are pretty constrained and where we have problems right now that cause congestion on really constrained networks. That are some items that we would like to work on. And so I think that that's already in charter. That bullet is pretty broad, but the efficiency part is really something we would like to work on in the near future.
Okay, thank you. Esker?
Skodek. So I think these bullets look good. Yeah, maybe except for the conflicts part. I think the background is that it's of course between fresh and stale data, but with the current MDNS, the fresh data is treated as a conflict, basically. So that's the problem. Or the stale data could be treated as a conflict as well. So that's where the confusion maybe between the terms comes from. But okay, we can reword that. And the other thing was I looked at the existing charter text, and it's pretty long, and also was written a long time ago, it seems. So maybe all the references to what's going on in the world, etc., need to be updated. So we can replace ZigBee IP by Matter, for example, or something like that. That looks good for the rest. Thank you.
Cool, thank you. So, I'm thinking we will, yeah. Eric, if the chairs work with you on a new charter, which we can then put to the list, or how are you seeing that we progress this?
So Eric Vink again. So the usual way of doing it, we discuss, we make a first round between the chairs and the AD, then we go to the list and wait for, not an official group last call or whatever, right? But we wait a limited amount of time. As far as I know, it will be Thanksgiving in US, so maybe until mid-December. And then I start officially the rechartering on data tracker that goes as well by the IETF last call and so on. So
okay,
I think we can most probably, the three of us work next week or the week after and launch the call for comment until mid-December, something like that. And everyone in the list is welcome to provide feedback, really, right?
Yes.
It's not the three of us only.
Yep. Okay, so that's covered. So, yes. Yep.
Okay, very good. Welcome, everyone. So I made some slides to introduce TSR, not too much. And for the rest, there are open issues listed in the slides. So to help summarize what the issue is and maybe also what the proposal is there. And we need to keep track of time, I think. I'm not sure if we even get to them all, but that's not a problem. So we can see how far we get with that. Yeah, yeah, that would be good to have at least an idea of that. Yeah, we are now at version 1 of the draft. So, and this is just to recap TSR. So we have the basically the TSR eDNS option to be used by, for example, advertising proxies. So those are listed here. The two boxes here are called Snack Router, making some link to the Snack Working Group, who defines this type of router that contains various features. And there are also 6LoWPAN border routers to connect to a 6LoWPAN mesh network. So that's why they're called 6LBR. So we have two of them. So you need at least two to kind of see where the problem is here. So the SRP client is, in this case, in a mesh network. It uses unicast to do an SRP update, sending its services to an SRP registrar. It could be maybe picking the closest one, or randomly selecting, or picking the one that it could find on the mesh network. So that's number one. And that basically sends an MDNS probe, and after that announce with the TSR option to advertise the services also on the AIL, the adjacent infrastructure link. So that enables the MDNS client on the top right to do, for example, a query for those services, or to cache them. Well, what could happen next is that basically the SRP client maybe moves around, or reboots, or wants to refresh, and then the update ends up at the other SRP registrar. So all snack routers are basically obliged to have an SRP registrar in there, so for making the service registrations. So this gets basically probed as well. Normally you would see that the snack router number one would basically say, hey, I have those services. So then the probe would basically fail. But thanks to TSR, basically the left one, number one, knows that, hey, I have stale data, so I will just clean that up, and the other one takes over basically. So it can successfully probe and announce its data there. So that's what TSR is basically defining. And for the MDNS client, well, nothing much really changed. It just sees the servers on the AIL, including the same IP address of the client that registered that service. So now the updates, version 1, it's not so much. We added some terms and definitions section, and trying to use consistently the same terms for the same things. This is always the first thing I do when I go work on a draft. Also, references were cleaned up, so like picking the right ones and the most recent ones. And we are now in Markdown as well. So this makes sending pull requests, if you want to do that, a bit easier. You don't need to worry about closing XML brackets somewhere in a long list. So I personally like that. Ted might disagree though, but okay, we'll see. So what about the open issues to discuss? Well, I put this one here first, that I think we've been discussing recently also. So this is referring to a piece in the text that is highlighted here in yellow. So the context of this is basically that a probe is being done. So somebody registers service at the SRP registrar, and now the registrar says to the advertising proxy, please advertise it. And basically that's going to do a probe for the data. Now there could be existing data already for that name on the link. And that existing data could have a TSR option in there. So this is about comparing the timestamps, so to speak. It could also be that this MDNS registrar that is, needs to do that registration on the AIL has something in cache already. So basically it had a cache announcement previously. So there are some possibilities there. So it could be that the known time in the cache of the MDNS registrar is more recent. So the TSR time. It could also be that both times are the same, or it could be that the proposed time is more recent. And so what we want to do is what it says now, if both types are the same. So basically it's highly likely then in that case that it's about the same data, because the time since registration is equal. So the idea is then that probing is not necessary anymore. So this is what the issue discussed. Maybe I'll show it on the next slide, and let's Ted give an opportunity to comment.
Yeah, sorry. Could you go back to the previous slide?
Sure.
Yeah. So you were saying that it probably isn't a conflict, but actually, I just wanted to clarify that one of the things that we fixed in the sort of recent changes to TSR was to say that if something if the data doesn't have the same source, it's always in conflict. It doesn't matter what the TSR value is. And so,
That's right.
so we only actually care about the TSR offset if the data is definitely not in conflict. So I just wanted to clarify that so that people
Sure.
don't misunderstand that part of it.
Yeah, so this is indeed about the data from the same source. So it uses a key basically to also sign the data, so you can, or at least sign the updates, so you can know that it's from the same source. Yeah. So maybe that case is also likely because what could happen, for example, is that device registers at SRP registrar number 1, and then very quickly within the same second registers at number 2, for example. Then you could get things like this. But we would need to cover all cases, of course, in this logic. So the idea was the original text says it's put in a probing state. Probing means sending something. If you can avoid sending something, that's always better. So maybe there's no need to send something here. Yeah, and I looked at it, and I think here in this case the registered data is already in the cache of the local MDNS registrar. This is the component that has to do the actual probing and announcing on that device. And same timestamp means that, well, normally that should be the exact same data. So I wondered, is there even a reason to announce? That's also a question. So maybe you can skip the probing, but then, yeah, you might also be able to skip the announce part. Yeah, so it could, that's if you skip the announce, that could basically lead to a situation that basically a device registered data that gets accepted, but is not announced immediately on MDNS. And the implication of that is, again, if you look at the specifications or if you look at the logic, then I think we also discussed that in the GitHub issue, is that this registrant, basically, that's the component on the node that is requesting for the update to be made. So in this case, this is the advertising proxy, cannot submit multiple updates with different data within the same 1 second period. So that's basically...
Sorry, Esko, I was just gonna,
Yes.
I just realized that there's a reason why we can't not probe, or at least we have to announce it. And the reason we have to announce it is because there may be stale data in other caches and we need to clear that out.
That could be, yes. Okay, to clear out all the caches, maybe, yeah. And that's for the announce part, basically. Yeah, and here I was just saying, if you don't announce, then you have to be careful because that means also if a client registers 2 times different data in the same 1 second period, then yeah, the second time it will not be announced basically, and it will have the same TSR value if you round it to seconds, basically. But okay, so that's for the announcing part. So what about the probing part, Ted? Do you have any idea about that?
So I don't think we need to probe because we've already probed, right? We already think we have correct data.
That's right. That's right.
And so we can announce the data, and if it turns out that that somebody else has more recent data, then they're going to. I think if we announce the data, they're going to send a. They're going to. Oh, actually, that's a good point. Maybe we do need to probe just to avoid that. Okay.
Well,
I thought we could get away with that.
It's not that
but
easy
yeah,
as it
I
sounds,
think. I mean, actually, Stuart's in the room, right? I added him in the GitHub issue, but I don't know if he saw that. So it might be worth. We should definitely zero in on an answer to that question, because it sounded really good on paper when we were talking. Well, sort of when I was commenting on the issue yesterday, but now that we're sort of thinking about it again, I'm realizing that maybe I was totally wrong.
Okay, so that needs some more thought. And I added this part, which might need to be respected anyway. So this is about the basic MDNS requirement of 1 second. So, so basically, if you have a DNS responder, in our case, this is the advertising proxy. you could say that it must not send updates too frequently. It's like, okay, I have a service, and then 100 milliseconds later, oh, I have a service with a different port, or the same service with a different text record. That kind of thing. So we should anyway avoid those kind of situations. But maybe that's not specifically something for TSR draft to consider, more for the advertising proxy. But this is good to keep in mind in any case. It also holds for any things that uses TSR, I think, too. Don't send too often updates. Stuart.
I'm Stuart Cheshire. Just a quick comment on that. Remember, the existing RFCs are not holy scripture.
Right.
We wrote what we thought was good guidance 20 years ago. And that seemed like, barring new information to the contrary, this seems like good guidance. Any of this can be updated by a newer
Right.
RFC. So we should think carefully about the implications of changing this, but we can if it's appropriate.
Right, yes. Yeah, I agree to that. Okay, maybe if no more thoughts about this, we could just jump into another issue. This is basically the issue of multiple proxies. It might be that this is not a very common situation, but it still could happen. So the assumption is that there could be more than one MDNS registrars, like, for example, the snack routers I was talking about, that have registers data for the same name. And this could happen in specific cases. For example, if snack router 2 missed the probe and announce, that was done by snack router 1 due to unfortunate message drops on multicast or maybe some temporary cable issue. So its cache was not cleared. So now we have 2 snack routers sitting on the same link, which have the same data with different TSR values, so with different registration times. And what could happen now is that basically someone queries for the name to get a service or a host name. And then the one that has the oldest data, so the stale data, answers first by random chance. So yeah, I'm just wondering, should we actually clarify how it works? Because we have requirements to that will basically say what how to handle those cases, but it will not actually, the current text does not state the outcome. So the outcome is, I think, that if an MDNS query is sent in this case, then a stale answer might be sent first, but it's then followed by a more fresh answer, because the one with the fresher answer also has the record, so will also answer the query. And the reverse is far less likely. So you will not get first a fresh answer and then a stale answer, because the one with the stale data will clear its cache. Ted,
yeah.
Any comments?
So yeah, a couple things. One is, yeah, it's totally possible that this can happen. And I thought the text covered it sufficiently, but if you're saying it doesn't, then we definitely need to clarify it. It should definitely be the case that if we receive a stale answer and then we receive a fresh answer, that the fresh answer replaces the stale answer, assuming that the query is still active. Because of course, one thing that can happen, which is actually not great, is that you've got somebody doing an MDNS query, they get an answer and they cancel the query as soon as they get the answer. And then that would mean that they would wind up with the stale data. The other scenario to be aware of here is that you have an MDNS server on a device and it gets a query and it has stale data, right? And it gets a query from a local consumer of MDNS. It's just going to answer out of cache. And I don't know if it's going to send anything on the wire at that point. And if it doesn't, then we're never going to get the fresh data. So
Right.
that's a potential issue.
Yeah, it also sounds somewhat unavoidable in that case, right? Because it can also happen with current MDNS if you just happen to miss the updates and you have something in cache that's still valid.
Yeah,
right.
exactly.
So that's not, yeah, maybe not easily solved. Yeah, so I don't know, the requirements are all in there to handle the case correctly, I think. And just a question like, okay, do we need more text? I'm not even sure myself. Maybe I'll think about the
Okay,
wording
yeah,
for that.
let's check that out and let's talk
Yeah.
about that offline and figure it out.
Yeah, and yeah, this is maybe the question you just pointed out. So you have a query sender who is sending a query. What if it already started to use stale data, indeed closed down its query, is not expecting more answers and just started to use that? So first thought is, well, maybe it should wait a little bit longer if it's aware of TSR and it sees a high TSR value, for example. It could just wait a bit longer. That's one thing it could do. Maybe we don't need to require that actually. But the other thing is that we could also say, well, maybe the MDNS registrar that has fresher data would respond more quick. And if someone has stale data, like it's already an hour old or multiple hours old, whatever, then it will just respond more slowly in a way to give basically space for the fresh responses to come first. That's just an idea that could be done.
So, yeah, one thing to say about this is that, or maybe Stuart's going to get up and say the same thing. Canceling the query when you get an answer is not really the right time to cancel it. The time to cancel it is when you've actually established a connection with the device you're trying to talk to. But I'll let Stuart talk.
That's a good point.
Yes, you're right, Ted. This is intimately linked with happy eyeballs.
Right.
And a client doesn't need to know anything about TSR to know basic principle of networking is information changes over time. And the information you have at time t might turn out to be stale at time t+1. So a robust client already has to keep its discovery operation running until it has succeeded. That's the happy eyeballs part of it. And that has been true since the dawn of multicast DNS, and TSR doesn't change that. And if you write an application, I mean, it's just like going back to the 90s. If you call get host by name and only look at the first IP address in the array, you're going to have a fragile client that doesn't work very well. And this is just the same thing for the modern era.
Right. Yeah. Okay. So we expect indeed the query sender to do just that. Actually, yeah. Okay. Very good. So it might be that solves it already then. That's maybe, yeah, if we expect the query sender to do that. So we don't
Or a
need
different way to look at it is if they don't do that, we can't really help them.
Right. Yeah. Right. Good point. Yeah, so I think another question that came up, should actually an MDNS registrar suppress its answer if another registrar already answered with the exact same data? So I'm not sure if this is a really practical case, but it could happen. Basically, someone answers with stale data while you have fresh data, but you also see like, hey, the stale data is exactly the same as the fresh data that I have. So should I still answer? That's basically the question. I'm not even sure if we expect those devices to be able or to compare all these records. So everything they see compared to their own.
Yeah. So the answer there is yes, we should respond. Because we want to flush the other cache. Like we've gotten a hint that somebody's got stale data. We want to fix that. So it's not so much to help the querier as it is to help the guy that's got the stale data.
Yeah. So I think one final thing is that I wanted to look at is I understand that's basically you send basically message to update the others who have stale data. I think it's interesting, would be interesting at some point to look like, okay, does this increase the number of multicast messages a lot on the AIL or not, to go through some scenarios, but that's something for another time, I think. But I think that's interesting to look at. So we should not have an explosion of traffic, let's say the more of these snack routers we add on the link. So keep that in mind. And my time was up, I think, so we'll better go to the next session, I think. Yeah. Okay, no, I think it's okay to just go to the next topic. So they have also time for the thing at the end, which I'm also very interested in.
So what do you want to do about advertising proxy? Because we don't have sorry. So what would you like to do? Is this on? Or did we try
Yeah,
to-
maybe
Oh, okay.
ask Ted. So what would he like to do? Or Stuart?
Well, yeah, I mean, let's
One of the
resolve
others.
these open issues. And once we've resolved them, then we can publish an update. I mean, we should be pretty close to done at this point. So, you know, ideally we should go to WGLC at some point fairly soon.
Yeah,
But
for
obviously we need to resolve the open
TSR
issues first.
For TSR, I think so. Yeah, we were just actually talking about the next agenda item already. So that we have advertising proxy.
Oh,
So
right.
there are
Well,
no
so that
slides for that.
I have no slides. I mean, basically the status of the advertising proxy is that we've been trying to get TSR done because it's sort of a prerequisite for advertising proxy. And then once we get TSR done, then we can go back to working on advertising proxy because, you know, I need to do an implementation of the new version of advertising proxy just to make sure that I believe that the document is correct. And, you know, so I very much would like to get that work going again. And I think those are the two things that stand in the way from my perspective. Doing an implementation of the new version and getting TSR done.
So if you would like to talk a bit more about TSR, you have that time and skip the advertising proxy. Then we still have time on the agenda.
Okay, yeah, that's also fine. And yeah, I think for advertising proxy, we could also work indeed for an update, like an intermediate update, just to keep the document alive. Also, I can also help there. So let's see. Did we have other things on the agenda? This is the last slide, I think, or not? Or did it just stop? I think I had more actually.
I think. So did you click a thing? Yes. Oh. So you had 2 more slides on that. All right, let's go back.
Then we have some extra time then to go through those. So shall I click to that? Oh, you already
I
did.
think it's, yeah, it's off.
Let's see. So this is, let's see. Yeah, the question was, issue here was about, suppose there are multiple advertising proxies on a link and some of them use TSR and some of them maybe not. So the point is that the MDNS registrar might see non-TSR, MDNS advertisement for a name that it has registered. So I was looking in the document here, and we do have a section basically processing messages with TSR, but there was no specific section that basically talks about what to do processing messages that do not have the TSR option. Of course, we have section 3.1. So this is about doing a new registration with probing and announcing, but it's not really talking about, okay, what do you do if you already probed and announced records and now you get, basically possibly conflicting record, which does not use TSR. And that is being basically sent on the link. Some options are, well, you could say you mark it as a conflict and clear from the cache. So maybe your client has to change the name. Or you could say, well, we keep it in cache and try to get the other guy to mark it as a conflict. So that's also possible. Ted, any opinions maybe from you?
Yeah, so generally speaking, what I have done in the document about stuff like this is defer to the RC 6762. So there isn't like a perfect way to solve this problem. If we get a conflict like this, we're kind of screwed, right? Like all we can do is just pick one or the other. And so there's no real point in TSR changing what we pick. So I believe the current behavior is that when somebody claims a name, whoever had previously advertised the name sort of reports it as being in conflict and does a name change. And I think we would probably continue to do that. But we don't really need, I would prefer not to say anything in TSR about this, but I'm open to you debating me on this point.
Okay.
I tried to be clear in the text that I wrote that we would just always, if the TSR isn't present, or if the TSR identities don't match, then we just handle conflicts exactly the same way that we do in RFC 6762.
Right. Yeah, that seems like a good thing. Maybe I can just have a look if I could come up with some sentence somewhere to just point to that. For other basically remaining cases are handled like there, just as an informative pointer. I think there is one thing that could be an issue to think about if the conflict is basically detected, and then basically the local registrant is notified. In this case, this would be the SRP registrar that has data for a client. So it gets a message from the MDNS component like, hey, this is in conflict, please remove whatever you have. I don't think that SRP has any way to basically notify the client of that. So that's because the client update was already done before. So then you're kind of sitting there like, okay, my client doesn't know it's a bad name, but I still have to remove the name. And the client thinks that I'm proxying for him. So that's maybe a situation to think about.
Yeah, so one of the challenges with the advertising proxy is that we're taking in two namespaces and mashing them together. So MDNS is a separate namespace from whatever the SRP namespace is. Like,
right.
In Thread, for example, the SRP namespace is just it's default.service.arpa. We just use that namespace. So the SRP registration to the namespace default.service.arpa is actually not in conflict. The only thing that's in conflict is the advertising proxy part of it. And so how to actually deal with that is a big question mark. And what we do, at least the TVOS implementation, I don't know what OpenThread does, but the TVOS implementation right now just keeps the data in the sort of in the zone, and continues to operate and answer out of that zone, but not so basically it doesn't try to resolve the conflict. And because the usual user of this data is Matter, we don't run into trouble. Because Matter actually enforces that names have to be unique. So any kind of conflict isn't actually a conflict. But for other use cases, that wouldn't work. And, we talked about, doing a multi-subdomain, so in other words, like, zone A.local, and then having that be a different namespace so we can actually keep the namespaces separate. I haven't really experimented with that. I don't know if that works, but that's one way to approach it. But aside from that, I don't think we can really do anything about it.
Right. Okay. That sounds indeed good. Thanks for explaining. Let's see, then look at the final slide. This is more like a scope question. So we have SRP replication in the working group as an item. The question that I had is our specific requirements for how TSR works together with SRP replication. Are they actually in scope of the TSR document? I thought it would be maybe easiest to put that in scope of the SRP replication draft. So we have TSR basically mostly covering the case that I had in the first two slides, which is in a situation without replication between those SRP registrars. So there are two, and that seems to be a basic case that the TSR could already be helpful without even having replication. And if we decide, well, replication is not really in scope, then we can also kind of defer all items that are related to replication. And an example is this GitHub issue I have there, so that you wondered, okay, for example, in case there are multiple replicated proxies, like 10 of them, which one responds to query? Like all 10 suddenly? That would be strange. So it does bring up new problems, basically. Maybe we don't want it in the scope here. It would complicate things a lot. So any opinions on that?
I think you're right that we should defer that. It's not clear that we would actually answer that in the SRP replication document because it's not an MDNS document. But I think answering that question here, we'd basically be kind of going out past the sharp end of the rope. You know, we don't actually have an implementation that does anything about this, and so I would argue that this is for a new document, even if it's not
Okay.
the replication document.
Yep. Yeah, okay, I agree. So if the replication document is just about replicating contents, then it might not indeed include anything about the MDNS advertising proxy part, which could be in a separate document. I agree. Yeah, okay. Sounds good. So I've reached the end of the slides and happy to give the clicker to someone else. Okay, thank you.
Okay, so let's move on to advertising proxy. So we have a number of open issues. So my question to those who is it? Oh, all right. Let me fix the screen share bit.
So we move to info then.
Yeah, okay. So we're having trouble sharing the screen. So we'll move on to infrastructure while we work on that in the background.
So I guess that would be me. Yeah, so this was actually something that was proposed in Matter, in the Matter SDO, and the main proponent of it was a guy named Matthew Cardus, and unfortunately he changed jobs and is no longer able to work on it. So we are now in search of a new author, but or new co-author. But I'm a co-author on the document, so I'm going to present just because, you know, I think this is work that we should do. It's I think it's fortuitous. Like Matter still needs this work, and there are still people in Matter that are trying to make this happen. So I think, you know, this is ultimately Matter is going to do work on this whether we do or not, but I think it makes sense to do the actual documentation here in the IETF and not in Matter, because this is actually like a core piece of what we've been trying to do in DNSSD and historically for quite a while now. So let's go to the first slide. No, the next slide.
Slide control. If you put our
Oh, I have slide control. Ooh, let's see. Oh, very exciting. All right, so the problem basically, this is the problem statement that for the problem that Matter is trying to solve. So, and the problem is that we have, so we all know that MDNS over Wi-Fi has issues, right? It consumes a lot of airtime per bit compared to regular Wi-Fi traffic. And devices that do beacon skipping can miss multicasts. And when they miss multicast, they fail to discover things that they're searching for. Or in the case of devices that are advertising, they may miss a query and therefore not be discovered. So Wi-Fi is kind of not ideal for MDNS on Wi-Fi is not ideal. And in terms of actually fixing the problems with Wi-Fi, it's actually hard. Wi-Fi is deeply entrenched, and actually, you know, one of the reasons Wi-Fi is so fast is because of beam steering, and for multicast, you can't do beam steering. So we're kind of stuck with Wi-Fi behaving this way. Now, the case where this becomes a really serious problem is with battery operated devices that are on Wi-Fi. They want to advertise or discover services, and they can't afford to burn a lot of battery doing it because they need to survive for a long time on the charge in their battery. So the question is, how do we do this without using MDNS? How do we get multicast out of the picture? Interestingly enough, we had this same problem on Thread. And so the way we solved this problem on Thread was to do basically a full DNSSD service on Thread. So Thread devices that are on the Thread mesh, have a full service DNS resolver. They can do SRP to register services. They have a discovery proxy, and that allows them to discover, allows the clients on the Thread mesh to discover both other Thread devices and also devices on infrastructure. And they have an advertising proxy, which allows infrastructure clients to discover them. Basically the question is, can we do this just on regular Wi-Fi? And so what that would look like is basically what I just described, right? We have a full service resolver, SRP registrar, advertising proxy, discovery proxy. So this is all existing technology. The only thing that's missing is how do we actually publish the availability of this full DNSSD service on Wi-Fi, and how do we discover and use it? So that brings us to, I guess, sort of the sub-question of that is, who's going to offer this service? And one obvious, really great solution would be to have your CE router offer this service, or your infrastructure devices to offer this service. But rolling that out has been problematic in the past. And so, when we did Thread, we could have said, well, you have to buy a special Wi-Fi router to do Thread. And we chose not to do that because it would have just, basically rendered Thread useless. One thing that we can do is just piggyback on top of existing Thread border routers. And so that's actually sort of the short-term expedient proposal. Have Thread border routers provide a full DNSSD service, which can be discovered. Ideally also specify how to do it with the CE router so that we can, over time, try to convince people that build CE routers to provide this service on their router, which will give a better experience, but obviously is more work or more of a sales. But basically, the people that are motivated to do this aren't the ones building CE routers. So as far as how to advertise it, we actually had two ideas for how to advertise it. The most simple thing to do is, if you've got a device that's sending out RAs anyway, just have a router advertisement flag, an RA flag, that says, I'm doing full DNSSD. And then if that flag is present and there's no RDNSS option, then you just use the device that sent the RA, the IP address, source address of the RA, the source address of the RA as the address of the DNSSD server. If there's an RDNSS option, then you use the address in the RDNSS option. And this can be, because Thread border routers actually send out RAs with a router lifetime of 0, this actually works for both border routers and infrastructure routers. And so snack routers, let's say. And then you can tell which one is infrastructure because infrastructure will have a non-zero lifetime. So obviously you prefer to use that. And then it's also possible, though, that there might be some device that's on the network that's a non-router device, and it's going to provide this service. And so in that case, you can advertise it using MDNS. It's not great because you're still doing multicast, but you're doing less multicast. And the discovery is kind of tightly scoped. So you start to do the discovery, you get the result, you use the service, you can stop doing multicast DNS. So you're not doing multicast DNS for like hours at a time. So it's still a win. And you can also do it with DNSSD, right? Like with DNSSD over DNS. And the other advantage of MDNS is that you can provide additional information. Like, you might have a device that's got multiple interfaces. You can give information about those interfaces and how to query them individually, things like that. And also how to identify which interface you're on. So let's see. So, and then there's some behavior that's required on the requester as well. So you've got this device that's either trying to do service discovery or trying to register a service, and so it needs to discover the service. So basically, it can look at router advertisements. If it doesn't find it in the router advertisement, it can do a DNSSD query. As I said earlier, it prefers infrastructure. It still has to do MDNS if no service is available. So if you don't have a full DNSSD service on some device on your network, you still have to do MDNS, or else you just have to not work. Those are your options. There is some maintenance that the requester has to do because we don't have a way, at least we don't currently have a way of signaling, you registered, but your registration is going away or has gone away. So you need to register again. So basically there's a whole bunch of things that the device needs to do to track whether its registration is working. So that's the basic story. I don't know if anybody has any questions or is curious about this. In terms of, I guess, one question is whether there's interest in working on this other than from me and, the guy at Silicon Labs who's no longer going to do it, but maybe some other guys at Silicon Labs will be interested as well.
Is there interest from the working group?
Stuart Cheshire again. This may be unsurprising, but I'm going to say I support this work. Multicast on Wi-Fi has always performed badly since 802.11b, and it's only got worse since then. And multicast DNS was great when the average user maybe had 2 devices. And now you have, if you're using Wi-Fi for home automation, you have 100 smart light bulbs or switches or thermostats or door sensors. We're way past the point that multicast DNS breaks on Wi-Fi. And this is long overdue to do. And the insight we had recently is we can do it in a backwards compatible way. And it doesn't have to be built into the access point. In the short term, some other device can offer this service. Long term, we'd love every access point to do it. But it's like IPv6 adoption. If the only way to do it is to go from here to the full solution, that there aren't the stepping stones. And once we realize that there are stepping stones between here and the final solution, it becomes achievable. And the benefits are enormous in terms of more efficient use of the wireless spectrum, and more efficient operation of devices. So I think this is really important work and long overdue.
Eskodijk. I agree with Stuart here, so it does sound very important. Although I'm personally most focused on threats as a solution, I do think that if you have a service like this in the home router, for example, then you're kind of much less dependent on the services on threat border routers, which could be devices like, for example, TVs or voice assistants that take on this role, but can be easily switched off by a user. And now with having this in an infrastructure router, let's say home router, for example, that would make it potentially a much more stable service that can also be used by others. So in the end, you get a better working system. So I'm also willing to kind of contribute to that or to review things or whatever, whatever is needed. But I think we need more, maybe some more people as well to work on this.
Eric Weng, this time, not as a responsibility, just individual contributor. I think this is an important work to be done because MDNS over the Wi-Fi, I am one of those, Stuart home, having not millions of bulbs, but having a couple of them, and it's a lot of traffic. And the more and more I see AP disabling MDNS to save bandwidth. So if then maybe a good idea to prevent this. I have no time to work on this though.
Really?
What shall we do next?
Do you want to share if you can share the app?
I guess one question for Eric is this something that we can adopt as a working group document now, or do we need to? Is there a feeling that we should finish other work first? The reason I ask that is because this is this is hot with Matter right now. I'm actually going to the Matter meeting next week to discuss it. I may be able to scare up some people to work on it at the Matter meeting, and I think that would be. I'd like to see this work happen soon, particularly if we could find some more people to work on it.
So Eric Vink again. So honestly, that is not up to me. It's up to the chair to decide whether it's priority. I could imagine though this is a simple draft that could be done in parallel, but it's really up to the chair. For me, we can at least start working on it. Even we need to check whether it's in the charter, I guess so. But yeah, I would encourage you to start on this. But again, it's up to the chair, right?
Yeah. So personally, I'm minded that I think our workload is small enough that we should be able to add this one. So I'm thinking we should do a call for adoption. Do you agree, Florian? Yeah, Florian agrees. Yes, David.
David Redekop, Atom Networks. As a writer of a resolver, a zero trust resolver that does at the gateway what Microsoft Zero Trust DNS does at the endpoint, we would be in full support of doing this.
Thank you.
Okay, just quickly, Esko Dijk here. I just quickly wanted to check. So it looks like it's in scope of the new charter, right? If I read this correctly.
Well,
Yeah.
yes, we need to. So that being done, let's move on to removal services. Francois? Thank you.
All right. Okay, it works. Hi, everyone. My name is François Michel. I work at Apple, and I'm presenting today a new document that we're working on that is trying to address a practical problem that we have with SRP right now. So first, let's have a bit of context on how SRP is used today with Thread. So usually you have a house where you have a Wi-Fi network with your classical accessories, a laptop, a smartphone, a printer. And then you have your Thread network with a lot of accessories that are connected in a mesh fashion. And so Thread is a very low power, low bitrate network. What we do here is that a light bulb will register using SRP to the Thread border router. Let's say the light bulb here, it registers as the bedroom light bulb. And then the border router does MDNS advertising proxy. So if your smartphone wants to activate the light bulb, it browses through MDNS. The border router can then announce the light bulb, and then you can directly access the light bulb. Oh, I have an issue with the clicker. Okay. You can then turn on the light bulb directly through the border router by reaching the light bulb through its IP address using its Thread IPv6 prefix. And so that's how it works today. And so the issue here is that thread has a maximum theoretical bitrate of 250 kilobits per second. It's a theoretical one. It can be really much lower in practice. Thread must coexist with other technologies such as Wi-Fi, Bluetooth, and other thread devices. So it has to have access to the channel. It cannot always transmit. It has to do like clear channel assessment and all that. And if we want to handle congestion, one thing that we cannot really easily do is doing something like TCP does, because SRP registrations are really short. So you cannot start a connection and send a lot of packets, get feedback from the receiver and adapt your bit rates, because registrations are very short. So it's a one-off thing. And the thing is, Matter SRP updates can be pretty large for thread. So it's 2 packets right now. A first packet is sending the SRP remove all published service operation. So it's sending 300 bytes just for that, to say remove all the previous services that I registered. And then it sends a second update of 600 bytes saying now register all new services. So it can look pretty small if you are on the Wi-Fi side, but for thread it's pretty large, because 600 packets will be chunked into smaller packets of smaller frames of 128 bytes. And so one packet of 600 bytes is actually a lot of different frames that have to be transmitted over thread with like collisions that can occur and all that. Still, that's not too much if you have just one light bulb. The issue is that we can have synchronization events when all the light bulbs and other accessories talk all together. This can happen if, let's say, your IPv6 prefix changes on the thread mesh. Let's say if you reboot your border router, the prefix could change, or some events like that could cause all the accessories to register all at the same time. And we measure that it could take several minutes or several dozens of minutes, depending on your configuration, to just converge, so to just have all the accessories to register. Let's take a practical example where we have a simulated testbed, which is very optimistic in terms of airtime collisions. So it's very gentle. So it's very underestimating the time it could take to converge. And even here with 80 light bulb, it took more than 1 minute to have all the light bulbs to register. And if you look at the curves here, the green one is all the updates that are sent, and the yellow one are all the retransmissions that were sent by SRP. That means that a good part of the traffic was actually retransmissions. Why is that? It's because the frames were interfering in the thread network, and so they weren't delivered on time, and sometimes the SRP client is just spuriously retransmitting because the current packet is still being retransmitted, but it has timed out, and so it sends a second one. And so you have a lot of traffic that is actually retransmission. So it's a bad result that we have right now. And so that's why we would like to propose a new option for SRP, which is called right now the SRP removal services EDNS option. And the idea is just, instead of sending these 2 updates for Matter accessories, which are first remove all the services and then install the new ones, we send a single update with a single option saying, by the way, remove all the previous services. So you do both operations at the same time. So the nice thing is that the idea is that it is transactional. So either both operations fail or they both succeed. And it's idempotent, so it always leads to the same results, which is a good thing as well. So if we want to compare with and without the option, you have the 2 updates. The first one is remove all by setting the update list to 0. The second one is add the services by setting the update list to whatever value you want. And instead of that, you would just have a single packet, which consists of the actual new services that you want to register. So instead of 273 bytes plus 614 bytes, you just have one update of 618. So you have 4 additional bytes for the option. And if you prefer packet capture, you go from this to that. And that's a way for me to show you that we have running code. We have implemented that, and we could see that it actually reduces the number of packets. And we also have some measurements. I could not get the graphs for today, but we could see that we can reduce at least of 20 seconds the time for conversions in our simulated test bed. And we expect even better results in even more congestion networks. So that's it for me for that document. So we would be very happy to work with you if the draft is adopted to see how we can make it move forward. We'd like to make more measurements that we can show in the next meeting to see how it goes. And maybe it would be also an opportunity to do other bandwidth-based optimization. So we are also happy to hear about your ideas regarding that. And that's it for me. Thank you.
So Eric Vink, individual contributor on this one. So François, I think it is your first presentation at the IETF. Is it correct?
Not IETF, but DNSSD, yes, it is.
Okay, anyway, welcome.
Thank you.
My only concern with this would be, how would you know that all the SRP server apply this option? Basically, how we can have a mix with the new and the old one.
Yeah, that's a very good concern. So in Threads, we have a mechanism on having a version number to the SRP server, and so we can announce what capabilities they have. That's one thing. Second thing, if you don't have that, right now, the way it works in the draft is that if the server doesn't understand the update, the option, it does not echo it back. That means the server didn't understand the update, and so you have to send it again without the option.
Okay, thank you.
Any other thoughts from the working group? Is this valuable? Would you be prepared to contribute?
So needless to say, I consider this pretty important and intend to contribute.
That's correct. My name is also on the authors list, so I'm not sure if I'm allowed to say anything about that. But I think it's also worthwhile, yes, because of the large optimization you can have for these type of mesh networks or low bandwidth networks. And one other thought I just had about the version question and discussion. Yeah, you could always consider later on to have a kind of revision of basically the SRP document, to have like an SRP version 2 that says, okay, it's like SRP version 1, but you add maybe a couple of things or improvements we have done over time. But that's just an idea that could be done. So you created like a version 2 RFC basically, which includes mandatory support for that option.
Yeah, I mean, one way to approach this would be to actually just have this document update the SRP RFC rather than being, right now it's just like an additional enhancement, but we could say that this actually updates it, and that would make it more findable if people were, like if somebody downloads the SRP document, it'll say updated by, and so they'll know to go look at this.
I guess we can move on to the 6.0 presentation then.
Hi, I'm Donald Eastlake. I'm going to talk about 6.0 and how it relates to SRP also. This is supposed to move it?
No, the arrows.
Oh, hit the arrow. Yeah. Okay, sorry. Well, yes. So the service registration protocol uses a variant of DNS update request, and it supports this first come, first served naming. A lot of people probably know some of this, so I'll be moving along pretty quickly. And also I won't be able to give all the details, but that naming service lets you secure a name and show that subsequent requests are coming from the same requester. It sends a key RR to indicate what the public key is, and that initial request and the subsequent requests are signed by the corresponding private key. So 6.0 is basically a public-private kind of key thing. So what is the SIG0? It's a meta resource record, which means it's not stored in zones, just occurs in messages. It has the same structure as the RRSIG, which is used for securing data, but the kind of data covered, the type field is 0, which is why it's called SIG0, and there is no data type 0. So the corresponding key, depending on how you're doing, is either stored in zones, or in case of service registration protocol, is included in the initial message. So this just shows what a request looks like. You got the DNS request body and the SIG0 at the end of it. If you're doing a FCFS kind of thing, then the key in the initial request is in the request body. As I say, I'm glossing over a bunch of details here. You should go read the referenced RFCs and the draft to see what's really going on. So for a DNS update, usually the key is something which indicates authority over a zone, because for a DNS update, you're updating data, whereas for FCFS, you're just sort of reserving a name and showing you're the same requester for later requests. And it is also possible to use SIG0 to secure a T key to negotiate a secret key between two hosts for securing subsequent DNS messages. So he also provides transaction security. You send some request, which might or might not actually have a SIG0 on it, but when you send the response back to secure the whole transaction, the response has a signature on it, which covers the concatenation of both the request and the response. And that shows that the response is to that request, that your request wasn't monkeyed with along the way, and that the response hasn't been monkeyed, if you can validate that SIG0. TSIG is a similar thing, but uses secret key, so it's not used in SRP currently. And typically in the past required manually installing these keys at both ends, which is kind of a pain, but it is possible to use the T key RR to dynamically negotiate these keys. So if you do have public-private keys around and installed, you can then use that to set up TSIG. The idea is TSIG is more efficient if you can use it. So there are problems with the current TSIG, the current SIG0 rather, as you might notice from the low RFC number. It doesn't have any way to provide an additional extended error information, with both TSIG and TKey have. It doesn't have a field in it for the original ID. So when a DNS recursive forwarder forwards a message with a SIG0, it would normally create a new ID in the request that it sends. The forwarder would change the ID. I understand in service discovery and SRP, it's not a problem because you do not use normal, regular DNS recursive servers. You use SRP forwarder if you're going to use a forwarder, so it could keep the same ID. Bind does support a multi-hop SIG0 by forwarding using TCP and maintaining a separate ID space for the TCP connection. I think it may be the only implementation that does that. It's also not extensible. TSIG and TKey have specific provisions for adding information to them. And currently, more than one SIG0 in a message is prohibited, and there are people who want to be able to do that for various bootstrapping purposes and things. And there's currently no way to indicate anything about the state of the key. And this is a somewhat different issue. There's a separate draft, DNS op key state. And these are some examples of suggested key statuses that you might want to signal with a SIG0. So there's three general ways to solve this. There's some sub-variations. One is make a brand new resource record. Then you can put in whatever extra fields you want and solve all these problems. One is to overload existing fields. For example, because SIG0 is not stored in a zone, the time to live in it isn't meaningless. So for example, you could encode this additional extended error and the original ID into the field which is normally designated for the TTL. And you could put if you have a key state, you wanted to do that, you could put that into the class field. Class is meaningless there. The current document requires it to be a wildcard covering all classes of data. Or you could put it in labels, which would probably be a bad idea because it's enforced in bind that labels be the right value. And the third option is to extend eDNS with options. Then if you have, particularly, that's pretty simple if you only have one SIG0. If you have multiple SIG0s, you have to somehow link which of these options links to which SIG0 if that's relevant. And the current draft suggests using the key tag for that, which is possible, but not, not in my opinion, all that elegant, because there could be key tags collisions, which you have to avoid, and so on. So there's pros and cons to each of these methods. A new RR is very clean, but it's zero backwards compatibility, and deploying a new RR, especially one involved with security like this, is not trivial. On the overloading the existing fields, it's maybe sort of the easiest, maybe the sort of least resistance, but there are possible backward compatibility problems depending on particular browser code and things like that, and what specific sort of reuse you're trying to do. And that does not get you extensibility. I mean, there's only so many fields you could overload, and then you run out of space in the SIG0, and you can't generally extend it further. Extending with options, I guess it may be a little bit less bit efficient with options, especially if you have multiple different kinds of options. But the OPT options do solve the problem. And there's this question of just how you link them to the particular SIG0 that a particular option applies to. And key tag may serve that purpose adequately. So there is a current draft targeted at the DNSOP working group. Version 3 is current, and it does various changes from the RFC. The RFC is so old, it indicated that support for TCP was optional with SIG0. That's been taken out. It goes with the option way of extending. It includes a DNS0, an EDNS0 option to carry the original ID and extended error. It adds a section on how to do multi-hop, essentially, get special considerations on forwarding a SIG0 DNS message with a SIG0 for a DNS caching forwarder. And it does permit multiple SIG0s on a DNS message, but it sort of does a minimum extension. It does not, T-SIG, you can only have one, and it doesn't generalize that. And you can only have either one T-SIG, or you can have one or more SIG0s if this draft were adopted and approved. And the DNS, the key state draft has expired, but there's the name, you can find it pretty easily. And that's for synchronizing key state. So this is just sort of an example combining a couple different things of if you have a DNS forwarder in the middle, why you might want multiple SIG0s, and the problem with forwarding. The idea is you have some requester and maybe they need some authority to update a zone or whatever they're trying to do. So they have this SIG0A, which has to get forwarded all the way through to the server at the far end, but they also want integrity or some other authority to the forwarder, which is DNS forwarder in the middle. So there's a SIG0B that just goes there. And then on the return path, the server provides a transaction signature so that the requester is assured that all this stuff got through properly and everything, which is SIG0C. And it gets back to the forwarder, and the forwarder might want to add a SIG0 to demonstrate transaction integrity on the way back to the requester. And that's it.
So please join the queue. I'm interested to hear what. So yeah. Yeah, that's right. Yeah, so in general to the working group, just interested to hear if you think this is a problem worth solving, and if you have an opinion on how it should be solved.
So my name is Johan Stenstam, and I'm a co-author with Donald on this. This is not a question, more a clarification that the key state draft that was referred to that has expired, it hasn't expired because of lack of interest. It has expired because we were putting it on a back burner waiting for the desync record to be standardized inside DNSOP, which is now done. So this will be refreshed immediately after the IETF.
Thank you.
Donald, thank you for bringing this to the working group. I may be unclear on what the purpose is. Are you presenting this? Is this sort of for our information, just so we know what's going
Well-
on? Is there specific action you'd like from the working group?
I was requested to present by the co-chairs.
Oh,
So
Yeah.
well, that
I said,
answers my
sure.
question.
So we did cover this in a previous meeting, and the working group expressed interest in working on it. So it's tried to move that on. So, sorry, throwing pens around.
So it sounds like the focus is that this work is going on and we need to make sure we're aware of it and give feedback and make sure it doesn't inadvertently.
Currently doesn't have a home.
Yeah, I mean, I will probably try, I'll present it to DNSOP next meeting if, well, there's this process going on to reorganize possibly DNS working groups. Although, I don't know. I think that the way things are currently, DNSOP seems like the best place for it to go. And I will, if that doesn't change, then I will push it in DNSOP.
Yes, that would be my instinct as well. DNSOP seems like the natural home.
Right.
Yeah, so as information for that, Donald was presenting this in DNSOP on multiple occasions, I believe, and there was not a lot of interest there. And at one of the meetings, Ted joined the mic line and said, hang on, we're actually using this in DNSSD, please don't break it. And that's where this came from. Okay, since there's no interest in DNSOP, maybe bring it here.
Got it. I have a couple of quick questions.
Sure.
Is it possible to go to slide 4? And I'll make this quick, but I just want to give you this feedback. I believe, okay. Yeah, so very quick thing on slide 4. It looks like you're listing differences here and you say in DNS update, 6.0 indicates authority for the entire zone. And I might be misunderstanding, but I don't think it has to be all or nothing like that. I think it's entirely possible to say 6.0 means I have authority to do exactly the update I'm doing, updating my host name. It doesn't mean I can do anything broader than what I'm doing.
I think you're correct, and I'll claim that that's covered under my gross hand waving about how this doesn't include all the details.
Okay. And then slide 12, quick bit of feedback. And we have talked about this before. You have done some work here with the original ID to support this case of forwarding. And I'm just going to state my position, which is that I believe we have a way of forwarding messages. It's called IP packets. And I'm not yet convinced that we need an application layer, message forwarding layer to run on top of our IP message forwarding layer. In my view of the world, the requester talks to the server, and the only intermediaries on that path are what we call IP routers. And I don't see any compelling argument to have some application layer relay. So I think we're kind of out of time, but that's just some feedback that this seems like unnecessary complexity to me.
So a couple things. One is if you have a use case that requires a change in format or that motivates a change in format that is not itself backwards compatible, that is to say, you're going to need to modify both sides of the communication anyway, then you might as well define a new format. And you know, I think also, generally speaking, this is, you know, as a former DHCP person, our general assumption, which I think is also true for consumers of 6.0, is that updating the server is easier than updating the clients. And so it's more likely if you don't have backwards compatibility, it's more likely that a client sending a new option with a new format is going to succeed because the server supports it than vice versa. So personally, I feel like it would make a lot of sense to just say, oh, we think we need actually a different 6.0 format. Let's define a different 6.0 format, go forward with that and see if that works. But only if that's it can actually satisfy Johan's use case. And then, yeah, the other thing is like regarding forwarding, which Stuart brought up, we actually have a use case where we want to do application layer forwarding. But I don't actually intend to use the mechanism that you have described here to make that work. And I think that Bind also didn't use that mechanism. So I'm skeptical that this is actually necessary. And if it's not, maybe we shouldn't do it. But I don't have a strong opinion about that.
Eric Green, first as an individual contributor, when you propose a couple of solutions, overloading existing field, please don't do it.
Well, update currently overloads lots of fields. So it's not like this would be a new thing in DNS.
I know, but I don't like this technique. But anyway, individual contributor. Now, as a responsibility for this group, we have talked with the chair of the DNSSD, the chair of the DNSOP, and the ADs. So this work, which is mainly DNSOP origin, could be hosted here without any problem. There will be cross-adoption working and making group last call. Right, so that will be okay.
Okay.
My last point, I requested to add this errata processing. We have no time to do it right now, but if you can have a look at the email and reply to me, that would be pretty cool. When I say you, this is the room, right? Not you, Donald. Thank you.
Hi, Alex Kluter, CoreMem Limited. I recently have implemented 6.0 in a server, but based on the older 2970.
2931.
Sorry, thanks. And in there, because it says you can only have one 6.0, much like tsig, it's like there's my code, well, it's staging, but it would just break in view of this. It would see this and reject it as an invalid DNS request or response. How would we reconcile that? Is that just to be ignored?
There's going to be some level of backward incompatibility, I think, unless you do the field overloading and it happened to be very lucky that the field isn't being checked.
Okay, that was, it was just curious, had I missed something?
And you do need a little bit of text in the RFC in order to tell you what to do when you add multiple SIGs. In particular, each one has to sign it without any of the others. So they're independent and stuff like that.
I couldn't remember. I thought not D also only expected one. I've been trying to dig through it, but it's not just my crappy code. It might be someone else's better code.
Sure.
You might be there. Okay, thank you.
Welcome.
Okay, thank you. So we are at the end of the meeting. Just to repeat on the errata. So there's an email that's gone to the list. It's about an errata on DNS push. And it's about the fact that the reconfirm TLB is a unidirectional message and therefore no response should be generated. So it'd be good to get your opinion on that errata. Anything else?
Put on the slide. So Donald, I had just mentioned that there's some work with reorganizing DNS at the IETF. There's a mailing list for that, and there's also this something on the ops area agenda, which is today after lunch, session 3. So if you're interested in these things, please go there.
So that concludes the meeting. Thank you, everyone.